Hello everybody. In this short video I'm going to give you a couple of tips on how to run the chi-square test on the observed data that was collected on these pea seeds from a number of years ago that you're also going to analyze here as part of this practical. Now we have the data, the observations available to us in the Word file, but for your convenience I also save them within Excel as a CSV file, so an unformatted, comma-separated file. And now I've downloaded them onto a folder that I have on my desktop. Now I'm working on a Mac machine, but things should look pretty similar if you're also working on a Windows machine. The first thing that I'm going to do is I'm going to launch Rstudio. And within Rstudio I'm going to create a new project, and that helps to organize all the files together. So I'm going to go to this symbol, or you can go to File, New Project. They're both the same thing. And you'll be asked, where do you want to create a new project? In a new directory, so in a new folder, or do you want to use an existing directory? This is what I want. I want to go to the folder where I have saved those CSV files that I got from Brightspace, and I'm going to go looking for them. They're there on my desktop in a folder called Mendel P. So I select that folder and hit open, and now it tells me this is where my current working directory is. So this is the folder that OR is going to look to by default for reading in files, and it's going to write files out there by default if we need to. And I'll click Create Project. Now you see then Rstudio relaunches essentially, and we're given a clean, a fresh session. Now I'm not going to spend too much time going into what is Rstudio, but basically you've got a number of windows. Here's the console, and this is basically where we communicate with OR. So I can tell OR, tell me what 1 plus 1 is, and I hit enter and it tells me that the answer is 2. That's fine, but actually it's more convenient to work with a little text editor. So we can click this symbol above here or go to File, New, Script, and we're basically opening up here a new text file. So we can type things in here like hello, even hello, and if we press Control and Enter, that command hello then is sent down to the console below, and OR will tell us actually there's a problem, hello is not found. So OR is not particularly friendly when it comes to telling it things like hello that are undeclared. Anyway, not to waste any more time on this, we're going to read in the data that, as I said, has been saved as a CSV file already. Now, if we look over in this bottom corner, you can see there's a number of tabs, and one of the tabs is called Files. And here you can see the files that are available. So if I use the read CSV function, read.csv, it literally reads a CSV. I use round brackets, and if I hit the tab key, it'll show me all the arguments available in that function. So the file that we're looking for, I'll put inverted commas. Now I don't really like typing, so I hit tab again, and it'll show me, well, which is the file. It'll give me all the available files. I'll just take the group 2 data for the moment. Now if I run this function, you'll see that it immediately goes down to the console, and it reads in that CSV. Now that's fine, but we'd like to capture that, because that's not captured. That's just printing out what's there, but nothing has changed in the global environment. We haven't actually done anything in OR, so we want to save that somewhere temporarily within OR itself. So I'll call it maybe group 2, because it was group 2, the student group 2 that recorded this data. I'll use the backward arrow. So this is the less than sign and the dash together next to each other, and this is the assignment symbol. So I'm telling OR, read in this CSV, and instead of just printing it out in the console, save it in something, or at least store it temporarily in something called group 2. Now again I'll press Control and Enter, and this is the same between a Mac and a Windows machine. Both times you use Control and Enter when you're in Rstudio, and that takes the command from here and it sends it down to the console and runs it. And you'll see now in the global environment group 2 exists up here. So again, if we just type group 2 and press Control Enter, it'll now print out what's in group 2. But that's very convenient because we can start to manipulate it. We can use square brackets to index, and for instance, if I put in the first row and the first column, I'll be told, well, I'm in this particular element here. which is f times p. So this is one of the crosses that we're interested in. Now, in this assignment, we're looking at chi-squared tests, and in R, there is already a function. So if I type in chi, chi, and press tab, then you'll see a number of available options within R. There is a data set on chicken weights. That's not really what we're interested in. We're interested in this guy, so I'll just select that by pressing enter. And now we're straight into the function chi-squared test. Now there's arguments available with this function, and you get a summary of them here. If you want to know more about the function, you can type question mark chi-squared tests, and here if I do control enter, over here in the help tab now you'll see all the information about what is this function and how do you use it. Now in our example, we can enter the observed values and the expected values, but it's probably a bit simpler just to test the observed, whether there is a goodness of fit between the observed and what we would expect normally given the proportions that we figured out in table 1. So we enter, the data that we want to test. I'm going to test these numbers here. So I'm looking at group 2, and I use the square brackets, the first row. So we're in the first row here. That's before the comma. After the comma, we're going to select these columns. So that's columns 5 and 6. I could also pull them out by name, but it's simpler here just to put in 5 to 6. 5 to 6. And just, if you want to assure yourself that you're working with the right data, just highlight that particular bit of the code, press Control Enter, and you'll see that the numbers indeed come up for transparent yellow and transparent green, which is exactly what we want to. Now, I don't think I'm giving anything away by telling you that the expectation here was that we should have a 3-to-1 ratio between these two classes. So 3/4 should be transparent yellow and 1/4 should be transparent green. So we can tell OR that's what we expected by using the P. This is a vector of probabilities. It has to be the same length as X, so it has to have of length 2. And the first item is a 3/4. We're using the concatenate, the C function in OR just to make a little vector. So it'll be 3/4 and 1/4. And again, let's just double check that this is correct. So I'll highlight that. And indeed, this vector is of probabilities 0.75 and 0.25. Fine. Now I can run that, and you'll get here immediately the chi-squared test for the given probabilities. So the data it's used, it's told me exactly what I inputted. There's the test statistic, about 7.5. The degrees of freedom is the number of different classes minus 1, so that's 1. And the p-value is the p-value associated with that particular statistic and the number of degrees of freedom. So it's looking at how significant is the amount of deviation from the expectation based on these probabilities and what we observe. Now I actually prefer to save the output of this, so I'll call it x2 chi-squared maybe. Again, I'll use that backward arrow symbol, Control Enter, and now if we highlight chi-squared, we get the same output that we had before, but we can go a little bit further. We can look at something like the observed values, and if I look at that using the dollar symbol, so I pull out the observed. So chi-squared, now this x2 object contains more than just the summary. I could also look at the expected numbers, and here it tells you straight away the expected numbers. So that's quite handy for filling in tables 2 and 3. Now, of course, I've only done this on the first entries of this group 2 table. You can do it on the second row, for instance. You could also do it on the third row, although if you have done your table 1 correctly, there's not too much point in testing the third row and so on. But anyway, you can perform chi-square tests on the various rows quite quickly and conveniently just by indexing out the correct elements of this table. So I hope this has been helpful to get you started in running a chi-square test using OR.